What's up everyone, welcome back to my channel. As you can see, this is a problem that I actually did not a long time ago, but this time I'm going to use an algebraic method to actually do it without actually splitting into cases as we did in the previous video that you actually saw. So we still have the same setup, except this time we're just again trying to take away n equals 0 case to make it easier on our algebraic calculation. So you can actually try to stop the video right now and try it yourself first. See if you actually use the same method as I do. Are you ready? Here we go. So what we're going to do this time is we're going to start with the definition of the power inside of modulus function. At least it works for any real numbers, which is when we have the power here that is non-zero, we can actually try to take that power out such that we actually get the following: d over dx of the function, which turns into absolute value of x only, and again we will just bring out the n to the outside of the absolute value. Okay, now we're going to try to think that absolute value of x is just some other variables u. Okay, now in this case we're going to take the derivative of d over du with respect to u to the n power, and of course we also need to do some chain rule later on, and we will see what we need to do. But if we treat this as u to the n power, by power rule, we will just carry out the power n to the front to get n times u, which in this case will be our x, absolute value of x, and then we need to minus 1 to the exponent, so that we get n minus 1. Now, don't forget that we actually need to do the chain rule. And what is the chain rule? Well, again, we have u, we set our u be absolute value of x. So if we try to take the du here, okay, then we have the absolute value of x on dx, which is again du over dx, or we can just say it this way. Yeah, du over dx is actually equal to the derivative of absolute value of x, which is in fact, if we try to think of the graph, is either positive 1 when x is greater than 0 or negative 1 when x is less than 0. So in other words, we actually just get the sign of the x value as long as x is not equal to 0. And again, here we'll just try to ignore, we'll actually take ignore the case when x is equal to 0 for a moment. Then here we'll get sine of x here. Okay, good. And again, that's because we are now changing it into du over dx for this u function here. So after the chain rule, we need to multiply back in, and again, what is the sine of x? It's just same as absolute value of x over x. So we actually have absolute value of x over x here. And then we can combine the absolute value of x with the absolute value of x to the n minus first power, so that we get the expression n times absolute value of x to the n power all over x. And again, we'll ignore, we actually ignore the case when x is equal to 0, right? Now, again, how do we tell what happened when x is equal to 0? When x is equal to 0, of course, when n is greater than or equal to 2, we know that we actually have more copies of x on top than the denominator. So after the cancellation, we also have enough copies of zeros here. So we will actually make the conclusion on the right and says that this holds true for let's see, x is not equal to 0 for any case, And then when x is equal to 0, when n is greater than or equal to 2, and again, we have already ignored the n equals 0 case, so don't worry about putting it in. Then we will say that this is going to turn down to 0 as we claimed. And then for the other case, we will just say that the derivative does not exist when x is equal to 0, when n is equal to 1, or n is negative. And again, when n is negative, it's kind of fair because even without absolute value sign, it's undefined anyway. So if it's already undefined for the original function, we cannot say that it has derivative at that value either. Now, for n equals 1, x equals 0, we just have the v shape again for the modulus linear function. So we actually have a sharp turn at x equals 0 or at the origin, which means that it's not smooth when x is equal to 0, and therefore it's not differentiable. The derivative does not exist. And that is it, which actually matches the results that we found in the previous video. Alright, I hope you all enjoyed it. Please don't forget to like and subscribe. And you can also try to check out my other playlists and find out my other videos. Don't forget to turn on the notifications so that you won't miss any of my new videos. You can leave your comments down below for any thoughts or any ideas. I'll see you guys in the next video.